Okay, here we have the derivative over here, and I'm gonna put it into here and see what happens. And this is something that you should know because this is how we're gonna solve for ODEs. This is one of the steps you need, one of the final steps you need to get ODEs down. So why we use unilateral one is because with this unilateral, we get this from it. A lot of textbook puts a minus to it, but that is arbitrary. You don't need to do that. The only reason they put a minus in it is a special case, and because this has a minus over here, because of how unilateral Laplace transform works. It's not really important. Don't bother putting too much effort to it. There's only special cases that only mathematicians probably care about. Very mathematicians that study Laplace like crazy. Engineers should not care about that. Anyways, over here, we get this over here, and we solve it out over here. As you can see, we get this format over here, and that's from integration by parts. As you can see, integration parts is, I believe, uv minus integral of, I forgot now, is probably du over here, and it's v. Yeah, that's probably correct. I hope I'm correct. I'm pretty sure it is. Yes, I'm pretty sure it's correct. And from that, you get this spicy form. Now, this over here, you could tell is actually just to y of what's again a Laplace transformation. That's why we change it to y capital. When we do see a capital now of y or x, that's going to be the Laplace of something most of the time. There's other times where it's a Fourier transformation, which is why you need omega for the Fouriers. We'll see what happens when Fourier happens. There's also Fouriers because sometimes you have a PDE and you need to do the Laplace and Fouriers at the same time, and it gets confusing and more confusing and more confusing. But it works out in the end. Now over here, you have a limit over here, but this goes to zero and this should go to infinity, but hopefully it's assuming that this goes to zero faster and everything is good. So we're hoping that that happens. And it does usually happen. So we're good. And over here, because this is e to the e, so a derivative of that is that again and again and again and again. So it'll always probably be that. And you see, that's how you get this in the end. That's pretty much it. Oh, did I forget a negative here? I think I forgot a negative. Yes, I forgot a negative here. That should be a negative over there. Should be negative initial conditions. Okay, so yeah, I will change that later. I need to rewrite everything and change that, but yeah, you got it.